The number of weather, climate, and water-related disasters has increased fivefold over the past 50 years, leading to losses of over $200 million every day. But where on earth is the worst weather, and why? We've covered increasingly destructive hurricanes, wildfires, droughts, and extreme rainfall, just to name a few. But it's time we asked, just how extreme can weather get on planet Earth? The answer isn't quite as straightforward as you might expect, so we're going to explore the hottest, coldest, windiest, driest, and wettest conditions that our atmosphere can create. It turns out there is actually a lot of agreement on one spot where Mother Nature's raw power reaches its peak, and honestly, its location is not where I expected. Thank you to Ren for supporting PBS. Water is our most vital natural resource. Humans can only survive a few days without it, so it seems fair to begin our exploration of extreme weather with the driest place on Earth, especially when it's as dry as this place. This 600-mile stretch of barren land tucked between Peru and northern Chile is the Atacama Desert. And in its hyper-arid core, certain areas are believed to have remained untouched by rain for centuries. To understand what can possibly create such extreme aridity, let's begin by looking up to a global circulation pattern called the Hadley cell. Its story begins at the equator, where the sun's intense heat causes moist air to rise. Once high in the atmosphere, it then cools and condenses, forming clouds and heavy rainfall, creating the world's lush equatorial rainforests. As this now dry air continues its journey away from the equator, it further cools and descends around 30 degrees north and south, where it suppresses cloud formation and leads to the creation of the world's major desert regions, including the Sahara, the Sonoran, and of course, the Atacama. But the Atacama's extreme dryness isn't only due to the Hadley cell. It's also intensified by something called the rain shadow effect. This is where mountains block prevailing moisture-laden winds, causing one side to receive a significant amount of rain while leaving the other side dry. And in the case of the Atacama, it's subjected to not one, but two rain shadows. So thanks to its unique position between the moisture-depleting Andes and the Chilean coastal range, and within the Hadley cell, the Atacama Desert exists in a kind of meteorological void, a place where the conditions for rainfall are essentially negated. Another especially dry place is Death Valley, receiving less than 2 inches of rainfall a year. But Death Valley is known more for its heat than anything else. In fact, it's commonly considered to be the hottest place on Earth. And in the US, extreme heat is the deadliest kind of weather. Death Valley not only holds the world record for the hottest air temperature at 134 degrees, but also hits triple digits on average 140 days each year. The first reason Death Valley routinely reaches such blistering temperatures is actually its dryness. Arid landscapes tend to experience greater temperature extremes. And at 36 degrees north, Death Valley is located right in the Mojave Desert, thanks again to our old friend, the Hadley cell. Water has a high heat capacity, meaning that it can absorb a lot of heat before it starts to warm up. So in places with more moisture, the sun's energy is spent on evaporating water rather than increasing temperature. But in an arid environment like Death Valley, there's very little water to absorb and dissipate the sun's energy. So instead, it all goes into heating up the ground and air. And the valley floor here is covered in dark rocks and soil. This causes the ground and the air above it to become superheated. On some occasions, ground temperatures here have even exceeded 200 degrees Fahrenheit. One last major factor contributing to Death Valley's extreme heat is the fact that it's one of the lowest points in the Western Hemisphere at about 282 feet below sea level. This exceptionally low elevation creates a sort of natural oven, As air descends from the surrounding highlands, it compresses and warms up, further amplifying the heat in the valley. Another meteorological phenomenon dictated by our sun is the wind. When the sun heats the Earth's surface, the air above the land warms up and expands, becoming less dense and creating an area of low pressure. The cooler, denser air over the oceans or other cool surfaces then rushes in to fill the space left by the rising warm air. So, wind, in a nutshell, is just air moving from high pressure to low pressure. Wellington, New Zealand is considered the windiest city in the world with an average wind speed of over 16 miles per hour. The main reason for this is something called the Venturi effect. Wellington is located along the Cook Strait, which acts as a wind funnel channeling air between North and South New Zealand. To help understand this, you can think about covering the end of a hose with your thumb. This compresses the water by reducing its exit area, forcing it to speed up as it escapes. But while Wellington may be the windiest city on Earth, there's somewhere orders of magnitude windier, where the atmosphere quite literally collapses under its own weight. High atop the East Antarctic Plateau at nearly 10,000 feet of elevation, we find the coldest place on Earth, as well as the source of its strongest consistent winds. But here the air is eerily calm and still. As it cools over the plateau, it becomes denser and heavier. And like water finding its path downhill, this chilled air is drawn downward by gravity, cascading off the elevated interior and hurtling towards the coast. This falling air is known as katabatic winds. And in Antarctica, particularly Commonwealth Bay, thanks to its uninterrupted slope hundreds of miles in length, these gravity-driven winds routinely reach speeds of 150 miles per hour. Each year, the monsoons bring frequent downpours and nearly 40 feet of rain to the villages of Mansinram and Cherrapunji in northeast India. Remember the rain shadow effect that leaves one side of the mountain range dry? Well, Mansinram and Cherrapunji, located on the windward side of the Khasi Hills, experience the opposite effect known as orographic lift. These villages lie directly in the path of monsoon clouds sweeping in from the Bay of Bengal. So when this warm, moist air encounters the steep terrain of the Khasi Hills, it's forced upward, causing the air to cool and condense, forming clouds that, in this case, release more water than anywhere else on Earth. While Mansinram receives slightly more rain on average than Cherrapunji, Cherrapunji holds the all-time world record for annual rainfall, receiving an unbelievable 1,042 inches, nearly 87 feet over a 12-month period. So far, we've looked at some truly impressive extremes of precipitation, temperature, and wind. But if you're looking for the single most extreme weather on the planet, measuring these different unique characteristics against each other kind of feels like comparing apples with oranges. So what if I told you that there was one place on Earth that had it all? Hurricane-force winds around 1 in 3 days out the year, the kind of cold seen few places outside of the Arctic, and extreme levels of precipitation. And that it's located in New Hampshire? Welcome to Mount Washington. Mount Washington is a modest mountain by many standards, standing over just 6,000 feet tall, but it's anything but ordinary. To many meteorologists and weather enthusiasts, it's known as the home of the world's worst weather. And in case you're thinking there's no way that it can really be as bad as somewhere like Antarctica or Mount Everest, check out these records. The Mount Washington Observatory, located at the summit, clocked the highest wind speed ever observed by a human at 231 miles per hour. And just this February, when temperatures plummeted to 47 below zero and winds gusted to 122 miles per hour, the mountain set the North American wind chill record at negative 108 degrees. Add to that an annual average of 97 inches of rain and 281 inches of snowfall, and you begin to see why this mountain in New Hampshire got its nickname. But how can a mountain barely 6,000 feet high in New Hampshire, of all places, be home to such extreme conditions?
A lot of our extreme weather has to do with our topography. That's sort of the first factor.
Mount Washington is the most prominent mountain east of the Mississippi, leaving it exposed to fast-moving air masses as they sweep across the country.
And we're the tallest mountain for about 1,000 miles. So of course, really there's not a whole lot of terrain that's going to slow down the jet stream as it makes its way through the United States into New England.
And not only is Mount Washington the tallest mountain in the area, but it also sits at the apex of the White Mountains, which leads to the Venturi effect, similar to what we saw in windy Wellington, New Zealand.
So there's a bit of a triangular shape to our terrain, and Mount Washington sits squarely in that. So winds are actually accelerated horizontally.
The wind also gets squeezed vertically as it races over and around the summit, creating a kind of double Venturi effect. Another factor for Mount Washington's extreme weather is its position at 44.27 degrees north, which places it almost exactly at the midpoint between the equator and the poles.
Being in the mid-latitudes, we get a lot of those storms. Frequently, cold air from the north is clashing with more tropical air to the south. And so Mount Washington, just by dumb luck, is sort of in that battle zone, particularly during the winter, spring, and fall months.
And the final ingredient that really sets Mount Washington apart is moisture.
But really what makes us different is that we're in a really moist area of the atmosphere. So moisture really allows for things like instability. And so just the tendency for air to rise or sink. We can have a really unstable environment up here on the summit. And so, yeah, we may not be the tallest mountain in the world, but in terms of moisture and just raw wind speeds, we have some of the worst weather on the planet.
So what do you think? Did we convince you that Mount Washington should be called home to the world's worst weather? Or do you think another place might be deserving of the title? Thank you to REN for supporting PBS. REN is a website where you calculate your carbon footprint, then offset it by funding projects that plant trees, protect rainforests, and suck carbon from the sky. By answering a few questions about your lifestyle, you can find out your carbon footprint and how you can reduce it. No one can reduce their carbon footprint to zero, so you can offset what you have left after reducing. Subscribers receive monthly updates from the tree planting, rainforest protection, and carbon removal projects that they support. You can get to see the trees you planted and what your money is spent on. You can learn more about REN's climate projects at ren.co.